Isochoric process. Okay, isochoric process means volume is constant, and the other things, pressure, temperature, the energy will be changes. Okay, let's see. So this is a gas container, is attached with a one pressure gauge. It is used to find the pressure of the gas inside it. Okay, so both the things we have attached here. First we have to put the heat energy, give the heat energy to the gas. Okay, so you know that very well. If temperature increases of the gas means it is leads to increase the pressure also. So pressure is increased. We noted here in the pressure gauge, but the volume kept constant. This is a condition for that isochoric process. So isochoric means put C means V, say CV like that. Curriculum weight means CV. So isochoric means volume is constant. In case of isobaric process, you know BP, pressure is constant like that. Okay. So it's easy to understand. When isochoric means volume is constant. Isobaric means pressure is constant. Okay. Skip the volume is constant here, but pressure will be increases. Okay. This is the best example of the explaining the isochoric process. When the food is cooked by closing with any lid on top it. Okay, so being the heating the vessel. Okay, and food is being cooked in this closed position. Okay, after that time what will happen? The temperature increases inside the vessel, so that is increasing the pressure. Okay, due to the pressure the lid is pushed outwards, so it will be fall down when steam is produced here. Okay, so this is because when the lid is closed, the volume, kept the volume is constant here. Okay, and if the volume is constant means the pressure will be increased gradually when heat is continues to separate here. Okay, so that the water stream sort tries to push out the lid, it shows the pressure is increases inside the vessel. Okay, now we'll see the what is the formula for the isochoric process. Okay, so C means volume will be constant, so V is equal to constant. The ideal gas equation, V is constant. From ideal gas equation, PV is equal to mu R into T. The volume is constant, bring it here. Okay, so we will have equation P is equal to mu R by V into T. Except temperature, mu by V is constant. Okay, so we'll write as the pressure is directly proportional to T, where mu R by V is equal to constant. Okay, so we write as this variable thing, right? We will write as P by T is also constant. Multiple temperature comes with divide here. So put initial pressure to the initial temperature is equal to final pressure with the final temperature or constant. So this is the formula for the isochoric process. Okay. Now here for isochoric process we know that change in the volume. So del V is equal to 0. So that work done is also 0 because of work done equal to P into del V. If del V is equal to 0 means okay, which leads W is also 0. Okay, so there is no work done by the gas in case of isochoric process. Okay, so then the first law of the thermodynamics becomes to find the internal energy. Internal energy formula del U is equal to Q minus W. Here W is equal to 0 means we write as del U is equal to K, which means the amount of heat energy supplied to the system it is same as the change in internal energy in case of isochoric process. Okay, next we will see the graphical representation of the isochoric process. So volume in x-axis, pressure in y-axis. V is constant. Suppose in case of the isochoric increased pressure condition, say this is a Pi, here is Pf, V is constant, so V is constant. So this meaning of what? Pressure is increased here. Okay, pressure is increased means what is the process name? It's called compression. So it's called isochoric compression. In case of Expansion means the arrow will be downwards. Here is PA, here is PF. Okay. The best example for understanding the isochoric process, which means the volume is constant. Okay, we see in automobiles, in the petrol engine, which undergoes the 4 processes. It's called 4-stroke engine. Okay, here the 4-stroke engine means this is a process. Okay, so during the first diagram shows, so this air is here. Okay, this is a piston. We have to rotate. So first condition is called adiabatic compression. So what will happen? Compression means pressure is increased. Adiabatic means temperature is not separate to the surroundings. So here inside is temperature is increased due to the adiabatic compression. Okay. Second thing, the increased pressure is here. Okay. The volume of that air fuel mixture inside it. Okay. It became volume of that pressure is constant. Even volume is constant means we can say it's called isochoric process. Okay. So in a isochoric process, the temperature, that is a temperature Q is inside, go into the compressor here. Okay, at a constant heat is being added here. Okay, so as a result, the temperature and the pressure are increased inside the things. Okay, during the third stage is called isochoric process. Okay, it's called adiabatic expansion. Expansion means is meaning what? Volume will be increased. Okay, volume is increased. Okay, at a constant pressure. Next 4-stroke, again same thing. While the increased volume, it will be try to go out with the amount of energy Q is go out. Okay, so it made the constant volume inside it. That's called constant volume heat ejection. It's called isochoric process. So both the cases B and D is made in the isochoric process, keeping volume is constant. Both the A and C is called adiabatic compression and adiabatic expansion. Okay, so these 4 strokes are done in that automobile. In case of petrol engine, we are used here. Okay, so this will happen for every 1 drop of the petrol with the petrol drop, making that function with the engine. Okay. Next topic is cyclic process. Cyclic means is one complete process. Okay, so the thermodynamic process in which the thermodynamic system returns to its initial state after undergoing a series of changes. Okay, so what is changes occurs on the system, it will come to the same position at final. Okay, since the system comes back to the initial state, which means there is no change in the internal energy, so you can write del U is equal to 0, where U is called internal energy, del means change. Okay, let's see the formula for that thing. The net charge or heat energy is equal to Q in minus Q out. Okay, equal to W. This is for a cycle process formula. Okay, so we'll explain this process in terms of the PV diagram. Okay, so here in a PV diagram for a cyclic process, so note that volume in x-axis, pressure in y-axis. So this the point C, suppose A C point here. At C is initial pressure and volume. Okay, say P1 V1. During that expansion, so it will be changing here to the A, and the final pressure of the expansion after expansion is P2, volume is V2. So what is the work done means? So from CBA, the work done, you will write all the region. Okay, so the diagram. So this is the work done by the gas. In case of the we can calculating CBA is work done. So you get the full region is called work done. Okay. Next, during that compression, the pressure will be increased, the volume will be decreased. Okay. So we note out that work done on the path A, D, C like that. Okay. So here is the initial, here is final. During that compression, the work done taking below the CDA path. Okay. This is for expansion, work done by the gas. Compression, work done on the gas, by the gas, on the gas. So different, we feel that. Okay. Now we calculated what is the net work done. See here. So the net work means the curved the region they showed here. From A, D, C, then C, B, A. That's called W1. A W1. The full is W1. Below is W2. So the net work done equal to what? W1 minus W2 given the total work done in the cyclic process. Okay.